Okay, so we talked about geometric power series. Remember, power series is just a series that has an x and an n into it. So let's kind of get started. I know we got to different places in different classes, so just kind of fast forward to what class you're in and then kind of continue watching from there. Okay, so a power series, we saw this this week in one of our practice problems, is a series that has not just an n in it, but an x. So let's say x minus 1 to the n. Okay, all power series are written in this form, x minus some numerical value raised to some n power. Now, that value is what we call the center. So we have a center at 1. And what that means for our graph, what we're doing is we're creating a polynomial function that matches a non-polynomial function. Okay, we tend to use polynomial functions. They're easier to derive, to integrate, to plug into. So we fall back on these series that represent these functions to calculate values that are not really calculated by hand, kind of like the square root of 2. Okay, so let's kind of get into that. So the geometric series, if we think about a rational, we're going to start pretty easy. We're going to start with a rational equation. If we think about the rational equation of 1 minus x, the form that it's in is very similar to our summation form for a geometric. So because it's in that form, we can easily rewrite this as a series where a value, in this case, is 1. I'm getting that dot thing again. Where a value is 1. And then if we think about it, that means our r value is x. Okay, so going back to a geometric series, that means we can write it as a geometric series as our a value times our, sorry, not 1. I don't know why I wrote 1 there. Our value is not 1. That would be bad. Our value is x. Okay, it's that value right there. Okay, so that's where I'm getting it from. So then we write the geometric series as our a value times our x to the n or to the n minus 1. Okay. And of course, we know that this summation or this summation formula right here is true if our absolute value of r is less than 1, meaning it converges. We only get value if our series converges. If it diverges, we're kind of out of luck. But because we're going to force it into this form, we're going to force convergence and talk about where our function converges. Okay, so that's kind of what we did here. Okay, we're going to do this center at 1, and all that means is we're getting into the form of 1. I know I'm all over the place, and I apologize for that. We're getting to the form of 1 over 1 minus and then x minus my center. Okay, so we're going to leave it there and then kind of go from there. So if we think about it, we can rewrite it in that form as a series involving an x and an n, so a power series. Okay, so when we expand it all the way up to infinity, we're going to get a polynomial, and that polynomial is going to actually give us the same values as this function for certain values of x, of course, where our function is convergent. So for this particular series, our series is convergent on the interval from -1 to 1. And what that means is if I pick any x value in between -1 and 1, my function, 1 over 1 minus x, and my series, x to the nth power, are going to be exactly the same. They're going to produce the same value. Okay, and we get that by looking at this value of where absolute value of x, because remember x is our r here, is less than 1. So if we think about that, we did a problem like this week, less than 1, and when we break it up, because our piecewise functions, our absolute values are piecewise functions. So that's how we're getting the interval of -1 to 1. Okay. So when we have a series that's centered at 0, that's nice. That makes it a little bit easier. Okay, because we don't have to worry about breaking up value. Okay, so our goal to turn a rational function into a series is to get it in the form of a over 1 minus r. Okay, so our goal is to get it into a over 1 minus r. Okay, now the r can be anything involving an x, but that 1 has to be consistent, and a can be anything we want it to be. Okay, so let's think about this idea of f of x is equal to 4 over x plus 2. If we look at this, I'm going to do some algebra, and what I'm going to do is try to force it to look like that. Okay, So the first thing I'm going to do is just a simple rewrite of the function. And we get 4 over, I'm just put 2 plus x. Okay, so my first problem is the 2 value right here. I need that 2 value to be a 1. So if I divide it by 2, I get that 1 value. So that's what I'm going to do. I'm going to take that and take this 2 over 2. But in doing that, that means I have to divide everything in my problem by 2, including the x and including the 4 up at top. Okay, so when I go to simplify that, I get 2 over 1 plus x over 2. And that's okay, okay? Because it's the biggest thing I want is a 1 right there. Okay, so the second problem that we're dealing with is not that 1 anymore, but it's the fact that we have a positive sign there. I need it to be negative because that 1 and that minus must be in the problem. So one thing that we could do to rewrite is just simply take 2 over and then put 1 minus and then a negative x over 2. Okay, and after doing that, that puts it in the form that we wanted, that a over 1 minus r. And what that means for us is our a value is 2 and our r value is negative x over 2. Okay, which means our summation formula for this particular function, and it changes as we change our rational function, starting at 0 to infinity, starts with our a value, and then of course our r value raised to some numerical exponent, or sorry, not raised to some numerical exponent, raised to n. Okay. The next thing that I want to concern myself with is, of course, looking at where these two functions are in fact equal. And we do that by looking at the interval of convergence. Okay, but we know things about the convergence of our geometric series, and that's what this is. All we have to do is look at our r value, the absolute value. Let me grab a pen again. So the absolute value, okay, third time's a charm. Okay, so the absolute value of negative x over 2 has to be less than 1. Okay, that's just what proves convergence for geometric series. So our geometric series tests are going to start coming into play here. Okay, then of course my goal is to solve for x here. So the first thing I'm going to do is split it up. Okay, so right there. First, and then if I multiply by negative 2, because I want to get rid of the 2 that's being divided and I want to get rid of the negative. So I'm just going to do it all at the same time and multiply everything by a negative 2. And what that means is I'm going to get a positive 2 here and a negative 2 here, and of course my x in the middle. But going back to algebra, when we dealt with inequalities, remember, if we are multiplying or dividing by a negative value with an inequality, it changes the direction of our inequality. So now our inequality is going to be this way instead for both of them. Okay, which means our interval of convergence, maybe if I write it the other way, where x is greater than negative 2 but less than 2, means our interval of convergence goes from negative 2 to 2. Okay, and that's it. Okay, so really what we're doing is we're taking a rational function and forcing it to be a polynomial. Okay, again, that's kind of how we calculate values. This is an easier one, and we're going to talk about some more complicated functions on Monday. Okay, but let's do another one. Let's do 1 over x. Now, the idea of it being centered at 1. Okay, and what that means is I need to get it into the form of a over 1 minus our x minus 1, the center. Okay. So that's kind of what I need to do. I need to get this 1 over x into that form. So I'm going to start off with the 1 over x. Okay. So now if I rewrite this, if I add the 1 that I need here, minus x, and then, plus x, and then minus 1. Well, let me rethink that really quickly. Eraser. Okay. Sorry, I'm trying to do the algebra in my head I apologize for the pause. Just go ahead and fast forward me until I start talking again. So my mind is straight. So what I want to do, of course, is to get this idea of minus 1 minus this idea of negative x. Okay, so what I want to do is, let me go ahead and rewind that. Fast forward, fast forward, fast forward. I apologize. Let's start off a little bit easier. Okay, so let's go with 1 over. So the idea here is we have this idea of 1 minus an x minus 1. And that's kind of a problem because we're going to have to add in a coefficient. We're going to try to get in that form. I mean, if we simplify that down, it's still 1 over, it's actually 1 over negative x. So that right there is where I'm having my problem. Sorry, guys. Go ahead and fast forward. Okay, so again, where I went the first time is kind of where we're going. I want to get that idea of 1 plus an x minus 1. Okay, and that right there is going to give us a value that's still equal to x, because if we add that 1 and that negative 1, that's going to give us that x value. So then the second problem in this one is the fact that our x is positive, and I really need, again, that sign to be a minus. So I'm going to do the same kind of thing I did in the previous problems. I'm going to kind of switch those signs to force that to happen. Okay. And I get that. Okay. In reality, and this, I guess this is where I was getting my brain messed up. In reality, that's kind of still that. It just has this idea of an actual negative. So one way that I could rewrite it is 1 over 1 minus a negative 1 times x minus 1. I know that seems weird. Okay, but that idea of trying to still keep that same value and get into the form that I want, which was, of course, this form right here. Okay, and I kind of have that now. So now that I have that, I can identify my a. So that right there represents my a value. And of course, that right there represents my r. Okay, so then I can rewrite it as a summation formula. Okay, so not 1 over. I'm losing my mind this afternoon. It's been a long week. Okay, so I apologize. So now the summation formula as n is equal to 0 raised to infinity. Then of course we have our a value, 1 times, okay, and I'm going to write it two ways, as negative x. Okay, this pen is also tired. Please put me on fast. Please tell me you did that. So x plus 1 raised to the n power. Okay, so that's one way we can look at it. But because of the way that we wrote it the second time, so this way now, I can also rewrite it as, and there's a whole bunch of different ways to write it. So that one in front, that one right there is not really important. But I can actually rewrite it as negative 1. Again, my pen doesn't like me tonight. Negative 1 times x minus 1. And all of that to the nth power, or the idea of each one of those to the nth power. And now if we think about it, we've actually forced this to be an alternating series. Okay, so let me go back and kind of talk through it one more time since I made so many mistakes. If we think about it, let's start here. Let me get a different color. Okay, so what I did from here is I took that idea and just kind of force this idea of 1 in front. And algebraically I did that by taking and putting a 1 and then of course subtracting out a 1 at the end. So if I simplify this form right here, I still get that 1 over x thing. Okay. Second thing I did was force the negative to be here. That's the negative right there. Okay, so that negative. And then if I do that, kind of distributing out or factoring out a -1, that's going to change the sign. So that's kind of what it did. And then again, I just distributed or factored within my actual parentheses as well. Okay, the whole point of this is that we're trying to manipulate it algebraically, following our algebra rules, to be able to get it into the form of a over 1 minus r, okay, with a given center. Okay, so there are a couple of different ways to do that. You're going to get a couple of different answers, but they're all equivalent values. If we took them all and put them in the calculator, they'd all give us the exact same value. And that's kind of the point here. Okay, the second thing I want to do is look at my interval of convergence. I can go to either one. Either one is going to give me the exact same value. So I'm going to come back to where we started here. Okay, so that idea of the absolute value of -x plus 1 has to be less than 1. So -1 less than -x plus 1. My pen does not like me today. I know I keep saying that. -1 less than -x plus 1 less than 1. Okay, so idea of subtracting out 1, I get a -2 here, less than -x less than 0. Okay, dividing by a -1 is going to get that to be +2. It's also going to switch my sign. And then, of course, 0. So really, if I switch that order, 0 less than x less than 2 makes more sense. Or the interval from 0 to 2. So any x values in between 0 and 2 is going to give us the exact same as the actual function. So the function and the series will be the exact same values anywhere between 0 and 2. Okay, I would have gotten that exact same thing if I would have dealt with that one right there as well. Okay, so I know a little bit confusing. We need a little bit of practice. There are 4 problems behind this one. I want you to try them out and then come in Monday with any questions you have, and I'll post all of the answers up online. Okay, have a good weekend.